My whole thesis really comes under the heading of understanding complex sociality. So when you think about people, we're really complex socially. That means we have a lot of relationships. They can be romantic, platonic, familial. But then when you think about relationships, it takes a lot of brain power even just to remember all the people we know, let alone our relationships towards them. So this has led to the idea that the more social a species is, the more intelligent they should be. And we wanted to test if this is true. Are more social species more intelligent than less social species? And we used cichlid fishes as a model. They're a really good system because you have a lot of really closely related fish that basically live the same way with only really differences in their behavior. So the poultry on your left are more social. They live in really big groups. They babysit each other's children. Whereas the temporalis, they're very close related, on the right, they are less social. They live alone or only in pairs, and they only look after their own offspring. So the only real difference between these two species is poultry are more social. So are they more intelligent? Well, we tested to see how long it would take them to learn that there was food hidden under some discs, and the results were really clear. The poultry were much faster at learning to find the food than the temporalis. So they're smarter, right? Unfortunately, as with everything we all do, I'm sure you all understand, it just gets more complicated. So when we tested this under different social conditions, that is, sometimes there were other fish around and sometimes there weren't, it gets really complicated. So are poultry more intelligent when they're happy? Maybe. The next step is to look at the brains of these fish, to dye them with fluorescent dyes and get a picture similar to this fly brain, to see if there are any structural or chemical differences in the brains that's underlying their individual ability to learn. So going back to people, why we think more social species should be more intelligent is quite straightforward. This highly social individual, Prince William, needs to be able to cognitively distinguish between the brunette that is his wife and the brunette that is his sister-in-law. And that's because if he tried to mate with his sister-in-law, it probably wouldn't go over well. And that's because in mainstream Western culture, at least, humans are generally expected to have only one sexual partner at a time. That is, be monogamous. So why would a species choose to be mostly monogamous? Another interesting question. Again, we looked for answers in fish. And again, we found it's a lot more complicated than we thought it would be. But the most important thing from this is, depending on the group you look at, you actually seem to have different causes of the same behavior. And that's a huge problem for all of these models, because if you look at a larger group, if you look on a larger level, and you try to put in too many groups with too many conflicting causes of the behavior you're interested in, what our models currently do, we found, is average out everything. And so you lose a lot of the nuance. And that's really what's going on in not just fish, but a lot of groups where we're looking at these models. So just in summary, complex sociality is very complex. It's a really broad subject, and we're only really looking at this in fish. But we found that it's remarkably easy, simple, and straightforward, and correct to extrapolate what we're finding in fish to other groups, even the ones we'd consider traditionally more complex, like birds and mammals. So by understanding sociality in these fish, we're understanding sociality in all animals.